Hello students, how are you? I hope all of you are good. In my previous 4 videos, I completed the introduction part for the vector algebra. It means I completed the introduction part for the first exercise, second exercise, third exercise, and as well as the fourth exercise of the chapter vector algebra So today I am going to solve some of the previous year questions and most important questions for your annual examinations. And here is the first question, and this first question is asked in the year July 2014, and the question is, find the projection of the vector 2i plus 3j plus 2k on the vector I plus 2j plus k. So let's say first vector is a vector. So a vector is equals to 2i plus 3j plus 2k plus 2k. And second vector is b vector. So b vector is equals to I plus 2j plus k. We know that the formula to find the projection of vector A on vector B, and the formula for finding the projection of A vector on B vector. Projection of A vector on B vector is equals to A vector dot B vector divided by magnitude of B vector. To calculate projection of A vector on B vector, we need two quantities. First one is A vector dot B vector and second one is the magnitude of B vector. So let's calculate the value of A vector dot B. A vector dot B vector is equals to, here A vector is given 2i plus 3j plus 2k dot B vector I plus 2j plus k. As you know that dot product of two vectors obtained by multiplying the corresponding coefficients of I, j and k. So first multiply coefficient of I with I. 2 into 1, 2 plus 3 into 2, 6 plus 2 into 1, 2, which is equals to 10. Therefore, the value of A vector dot B vector is equals to 10. Similarly, we need magnitude of B vector. So magnitude of B vector is equals to square root of the coefficient of I, that is 1 square, plus square of coefficient of z, that is 2 square, plus square of coefficient of k, that is 1 square, which is equals to square root of 1 plus 4 plus 1. So therefore magnitude of B vector is equals to root 6. Hence projection of A vector on B vector is equals to, value of A vector dot B vector is 10 divided by magnitude of B vector is root 6. So therefore projection of A vector on B vector is equals to 10 by root 6 units. I hope all of you understood. Let's start the second question. And the second question is, find the projection of the vector I plus 3j plus 7k on the vector 7i minus j plus 8k. So this question also asked in July 2015. So here also the same question, we need to identify the value of projection of A vector on B vector. So we know the formula for projection of A vector on B vector, that is what? Projection of A vector on B vector is equals to A vector dot B vector divided by magnitude of B vector. So we need the values of A vector dot B vector and magnitude of B vector. So let's say the first vector given in the question is A vector, and A vector is equals to I plus 3j plus 7k, and the second vector is B vector. So B vector is equals to 7i minus j plus 8. So first we need the value of A vector dot B vector. Therefore, A vector dot B vector is equals to I plus 3j plus 7k dot B vector 7i minus j plus 8k. So therefore, A vector dot B vector is equals to 1 into 7, 7 plus 3 into minus 1, minus 3, 7 into 8, 56, which is equals to 56 plus 7 is 63, 63 minus 3 is 60. Therefore, the value of A vector dot B vector is 60, and we need magnitude of B vector. Magnitude of B vector is equals to square root of coefficient of I in B vector 7 square plus minus 1 square plus 8 square, which is equals to square root of 7 square is 49 plus minus 1 square is 1 plus 8 square is 64. So finally magnitude of B vector is equals to square root of 49 plus 1 is 50, 50 plus 64 is 114. So hence the required projection of A vector on B vector is equals to A vector dot B vector is 60 divided by magnitude of B vector is square root of 114 units. I hope all of you understood. Let's start the next question. And the next question is, find the area of parallelogram whose adjacent sides are given by the vectors A vector and B vector. So this question asked in the year March 2015. So here we need to calculate the area of the parallelogram, and we know that area of the parallelogram when its adjacent sides are given, that is what? Area of parallelogram. Area of parallelogram when A vector and B vector are the adjacent sides of the parallelogram. So that is area is equals to magnitude of A vector cross B vector, where A vector and B vector are the adjacent sides of the parallelogram. We need to find the magnitude of A vector cross B vector, and we know that cross product of two vectors is obtained by the determinant method. So let's see here, A vector cross B vector, which is equals to determinant of. So first row is the unit vectors I, j and k, and the second row is coefficient of I, j, k in A vector, that is 1, minus 1 and 3. And third row is coefficient of I, j, k in B vector, that is 2, minus 7 and 1. So therefore A vector cross B vector is equals to, already you know that method of solving determinant, plus minus plus. So I into deleting this first row first column, minus 1 into 1 minus 1 minus 7 into 3 minus 21 minus into minus plus 21 minus j into deleting first row second column, 1 into 1 1 minus 2 into 3 6 plus k into deleting first row third column, 1 into minus 7 minus 2 into minus 1 is minus 2 minus into minus plus 2 minus into minus plus 2. Now see here, A vector cross B vector is equals to A vector cross B vector is equals to I cap into 21 minus 1 is 20 minus j cap into 1 minus 6 minus 5 plus k into minus 7 plus 2 is minus 5. Therefore, A vector cross B vector is equals to 20 I cap minus into minus plus 5j plus into minus minus 5k. So we got A vector cross B vector. Now we need the magnitude of A vector cross B vector, that is area is equals to square root of magnitude of A vector cross B vector is square of coefficient of I, that is 20 square, plus square of coefficient of j, that is 5 square, plus square of coefficient of k, that is minus 5 square. So which is equals to square root of 20 square is 400 plus 5 square is 25 plus minus 5 square is 25. So which is equals to square root of 450. And here 450 can be expressed as 225 into 2. And we know that square root of 225 is 15 root 2 square units is the required area of the parallelogram. I hope all of you understood. Now let's start the next question. And the next question is, find the area of the parallelogram whose adjacent sides are given by the vectors A vector and B vector. So this question asked in the year March 2015. Here also we need to calculate the area of the parallelogram, and he has given that A vector and B vector are the adjacent sides of the parallelogram. So we know that area of the parallelogram is equals to magnitude of A vector cross B vector. So first we need to calculate the cross product of A vector and B vector. So therefore A vector cross B vector is equals to determinant of where first row is I, J, K and second row is coefficient of I, J, K in A vector, that is 3, 1, 4 and third row is coefficient of I, J, K in B vector 1, -1, 1. Now A vector cross B vector is equals to I into deleting first row, first column 1 into 1, 1 minus 1 into 4 is -4, minus into minus +4 minus j into deleting first row, second column 3 into 1, 3 minus 1 into 4 -4 plus k into deleting first row, third column 3 into -1 -3 minus 1 into 1 1. I hope all of you understanding. Therefore A vector cross B vector is equals to 1 plus 4 5 I cap 3 minus 4 is -1 minus into minus plus 1 j minus 3 minus 1 is -4 minus into plus -4. Therefore A vector cross B vector is equals to 5i plus j minus 4k. So therefore area is equals to magnitude of the A vector cross B vector, which is nothing but square root of coefficient of I, that is 5 square, plus square of coefficient of j, that is 1 square, plus square of coefficient of k, that is -4 square. So which is equals to square root of 25, 5 square is 25 plus 1 square is 1 plus -4 square is 16, which is equals to here 25 plus 1 is 26, 26 plus 6 32, 32 plus 10 is 42. So square root of 42 is the required area of the given parabola. I hope all of you understood. Now let's start the next question. And the next question is, find magnitude of x vector for a unit vector A vector and x vector minus A vector dot x vector plus A vector is equals to 8. So this question asked in the year March 2015. See here, in this question he has given that a unit vector A vector. So therefore A vector is a unit vector. In this question he has given that A vector is a unit vector. So we know that unit vector means its magnitude is equals to 1. So in this question he has given that magnitude of the A vector is equals to 1. Also he has given that x vector minus A vector dot x vector plus A vector is equals to 8. So here also he has given that. X vector minus A vector dot x vector plus A vector is equals to 8. But in this question we need to calculate what? Magnitude of x vector. When A vector is a unit vector and x vector minus A vector dot x vector plus A vector is equals to 8, then we need to calculate the value of magnitude of x vector. See here, first thing, dot product by using the multiplication rule, x vector dot x vector dot x vector plus x vector dot A vector dot A vector minus into plus minus A vector dot x vector and then minus into plus minus A vector dot A vector is equals to 8. We know that dot product is commutative. Already I discussed when we are discussing about scalar product and dot product. So in my introduction part, I discussed dot product is a commutative. Commutative in the sense A vector dot B vector is equals to B vector dot A vector. So it means x vector dot A vector is equals to A vector dot x vector. So these two terms are same with opposite sign. So we can cancel this x vector dot A vector minus A vector dot x vector. And we know that x vector dot x vector is equals to magnitude of x vector square minus A vector dot A vector is magnitude of A vector square equals to 8. So in this question he has given that magnitude of A vector is 1. Therefore magnitude of x vector square minus 1 square is equals to 8. So therefore magnitude of x vector square minus 1 square is 1 equal to 8. Shift this minus 1 to right side, plus 1. So finally we got magnitude of x vector square is equals to 8 plus 1, 9. So therefore magnitude of x vector is equals to root 9. Hence magnitude of x vector is equals to 3. I hope all of you understood. Now let's start the next question. And the next question is, find magnitude of a vector into magnitude of b vector. So here in this question we need to calculate the magnitude of a vector and magnitude of b vector. If a vector plus b vector dot a vector minus b vector is equals to 8, and also he has given that one more information here, magnitude of a vector is equals to 8 times of magnitude of b vector. And this question asked in the year March 2019. See here, to identify the values of magnitude of a vector and magnitude of b vector, he has given that two information here. The first information is a vector plus b vector dot a vector minus b vector is equals to 8. Now see here, by using the multiplication rule, first a vector dot a vector dot a vector plus into minus minus a vector dot b vector, and then plus b vector dot a vector, then plus into minus minus b vector dot b vector is equals to 8. And we know that dot product is commutative, therefore plus a vector dot b vector and minus a vector dot b vector get cancelled. And we know that a vector dot a vector is magnitude of vector a square minus b vector dot b vector is magnitude of b vector square equals to 8. Now see here, this equation involving with magnitude of a vector and magnitude of b vector, but we need the magnitude of a vector and b vector. For that he has given that magnitude of a vector is equals to 8 times of magnitude of b vector. So in place of magnitude of a vector, I can replace 8 into magnitude of a vector. So magnitude of a vector is 8 into magnitude of b vector whole square minus magnitude of b vector square is equals to 8. Now see here, 8 square is 64 into magnitude of b vector square minus magnitude of b vector square is equals to 8. And in the next step, observe here, 64 times of magnitude of b vector square minus 1 times of magnitude of b vector square is equals to 63 times of magnitude of b vector square is equals to 8. So by this, magnitude of b vector square is equals to 8 divided by 63. Hence, now see here, now see here, by this equation, magnitude of b vector is equals to square root of 8 divided by 63. 8 divided by 63. And this can be expressed as magnitude of b vector is equals to square root of 8 can be written as 4 into 2 divided by 63 can be expressed as 9 into 7. Hence magnitude of b vector is equals to, we know that square root of 4 is 2 into root 2 divided by square root of 9 is 3 into root 7. So finally we got magnitude of b vector. And also we need what? Magnitude of a vector. To calculate the magnitude of a vector, he has given that magnitude of a vector is equals to 8 times of magnitude of b vector. And already we obtained the value of magnitude of b vector. So 8 into magnitude of b vector is 2 root 2 divided by 3 root 7. Hence, the required magnitude of a vector is equals to 8 into 2, 16 root 2 divided by 3 root 7 is the required answer. 16 root 2 divided by 3 root 7 is the required answer. I hope all of you understood. Let's start the next question. And the next question is, if magnitude of a vector plus b vector is equals to magnitude of a vector minus b vector, prove that a vector and b vectors are perpendicular. So this question asked in the year March 2016. This question asked in the year March 2016. See here, in this question he has given that magnitude of A vector plus B vector is equals to magnitude of A vector minus B vector. And we need to prove that A vector and B vectors are perpendicular to each other. We know that the condition of perpendicular to vectors, if two vectors are perpendicular, then their dot product should be equal to 0. So if we prove that A vector dot B vector is equals to 0, it means that the given two vectors A vector and B vectors are perpendicular. So to prove that A vector dot B vector is equals to 0, in this question he has given that, magnitude of A vector plus B vector is equals to magnitude of A vector minus B vector. So first thing, given thing is here, magnitude of A vector plus B vector is equals to magnitude of A vector minus B vector. See here, if a question consists A vector plus B vector, A vector minus B vector, so if the question consists the terms of this form, then the first step is we need to take the squaring. If you took the square, then half of the question will be solved. See here, so to identify the angle between A vector and B vector, here first thing I am going to take what? Squaring on both sides. Squaring on both sides. That becomes what? Magnitude of A vector plus B vector whole square is equals to magnitude of A vector minus B vector whole square. And by the algebraic formulas, that is what? A vector plus B vector or A plus B whole square is equals to A square plus B square plus 2AB, and A minus B whole square is equals to A square plus B square minus 2AB. So by using these two formulas, see here, magnitude of A vector plus B vector whole square can be done as magnitude of A vector square plus magnitude of B vector square plus 2 into A vector dot B vector, which is equals to magnitude of A vector minus B vector whole square is equals to magnitude of vector A square plus magnitude of vector B square minus 2 into A vector dot B vector. Now observe here, magnitude of A vector square, get cancelled on either side. Similarly, magnitude of B vector square, get cancelled on either side. So remains in the left side 2 into A vector dot B vector, and on the right side minus 2 into A vector dot B vector, minus 2 into A vector dot B vector. Now see here, in the next step, shift this minus 2 into A vector dot B vector to left. It becomes what? 2 into A vector dot B vector minus becomes plus 2 into A vector dot B vector is equals to 0. So therefore 2 into A vector dot B vector plus 2 into A vector dot B vector is 4 times of A vector dot B vector, which is equals to 0. So hence in the next step, A vector dot B vector is equals to 0 divides 4. I shifted this 4 to right side. It becomes A vector dot B vector is equals to 0 by anything is 0. So we proved A vector dot B vector is 0. It means if dot product of any two vectors is 0, then definitely that two vectors are perpendicular to each other. It means A vector is perpendicular to B vector, and that's what we need to prove in this question. I hope all of you understood. And let's start the next question. And the next question is, find the angle between the vectors I plus j minus k and I plus j plus k. So this question asked in the year March 2016. See here we need to calculate the angle between the given vectors. So let's say first vector is I plus j minus k, and second vector B vector is I plus j plus k. We know that the formula to find the angle between two vectors, we know that the angle between the two vectors formula, that is what see here, we know that angle between two vectors, vectors formula. That is what cos theta is equals to, that is what cos theta is equals to a vector dot b vector divided by magnitude of a vector into magnitude of b vector. So to identify the angle between two vectors, we need what? A vector dot b vector and magnitude of a vector and magnitude of b vector. So in this question already he has given that a vector and b vector. So first calculate value of a vector dot b vector. A vector dot b vector is equals to I plus j minus k dot I plus j plus k. We know that dot product of two vectors obtained by multiplying the corresponding coefficient of I with I, j with j and k with k. So in the first vector coefficient of I is 1 and in second vector coefficient of I is also 1. So 1 into 1, 1. Similarly plus 1 into plus 1, 1 and then minus 1 into plus 1, minus 1. So therefore a vector dot b vector is equals to, here plus 1 minus 1 cancel, remains 1. Therefore the value of a vector dot b vector is 1. And then we need magnitude of a vector. So magnitude of a vector is equals to square root of the I coefficient in a vector 1 square plus similarly j coefficient square 1 square. Similarly coefficient of k square minus 1 square, which is equals to square root of 1 plus 1 plus 1. Answer is root 3. And also we need magnitude of b vector, which is equals to square root of 1 square plus 1 square plus 1 square, which is equals to square root of 1 plus 1 plus 1. Answer is root 3. So we got the values of a vector dot b vector, magnitude of a vector and magnitude of b vector. Use these three values in the formula for angle between two vectors. We got the required angle, that is what cos theta is equals to a vector dot b vector is 1 divided by magnitude of a vector is root 3 into magnitude of b vector is root 3. Therefore cos theta is equals to 1 divided by root 3 into root 3 is root 3 whole square. So square and square root get cancelled. So hence the value of cos theta is 1 by 3. Therefore theta is equals to cos inverse of 1 by 3 is the required angle between given two vectors a vector and b vector. I hope all of you understood. And the next question is, let magnitude of a vector is 3 and magnitude of b vector is root 2 by 3 and magnitude of a vector cross b vector is 1. Then find the angle between a vector and b vector. So in this question also we need to calculate the angle between the a vector and b vector. So this question asked in the year July 2015. So observe this question. In this question he has given that, magnitude of a vector, magnitude of b vector and the magnitude of the cross product of a vector and b vector. When the magnitude of the cross product is known, then the angle between two vectors formula is sin theta is equals to magnitude of a vector cross b vector divided by magnitude of a vector into magnitude of b vector. So see here, already in this question he has given magnitude of a vector, magnitude of b vector and magnitude of a vector plus b vector. Just use the given values in this formula. So therefore sin theta is equals to magnitude of a vector plus b vector is 1 divided by magnitude of a vector is 3 into magnitude of b vector is root 2 divided by 3. So see here, in denominator I can cancel 3. So remains sin theta is equals to 1 divided by root 2 and hence theta is equals to sin inverse of 1 divided by root 2. Hence theta is equals to the value of sin inverse 1 by root 2 is pi by 4 or you can also known as 45 degree. So therefore required angle between two vectors a vector and b vector is 45 degree. I hope all of